Hi, welcome to Unit 5, Day 8, Types of Chemical Reactions. This is part 1 where we'll discuss single displacement reactions. So this week we've been learning about the 5 basic types of chemical reactions. And we're learning about these basic types of chemical reactions because by knowing the type of reaction, it allows you to predict the products from the reactants. And you can use certain strategies to balance chemical equations based on the type of reaction. This week we've covered synthesis and decomposition on Monday, and on Tuesday we covered combustion. So before we get into today's lesson on single displacement, let's just quickly review what we've learned so far. So in terms of synthesis and decomposition, for synthesis, that's a reaction where you have 2 or more reactants that combine to make one product. And an example of that would be the formation of NaCl, sodium chloride, from sodium and chlorine. In decomposition, you have one reactant that breaks down or decomposes into 2 or more products. An example of that will be the decomposition of ammonia NH3, so NH3 breaks down into NH2. For combustion reactions, we focus specifically on combustion of an organic molecule. But in general, combustion reaction just involves the reaction of something with oxygen to produce an oxide. But we wanted to narrow that down because there's a lot of reactions that can fall under combustion. So we narrowed that down to that of organic molecules. And in the combustion of an organic molecule, of course, you're going to have oxygen, O2, as a reactant, and your organic molecule. So those are your 2 reactants. And then the 2 products that you typically get are going to be carbon dioxide and water. So when you do a combustion of an organic molecule, you'll get carbon dioxide and water. And when I say a organic molecule, that's a molecule with that's carbon-based. So examples, an example of that would be the combustion of propane, C3H8, reacts with oxygen to produce CO2 and water. Now today we're going to focus on single displacement reaction, and here is our success criteria for today. First, we're going to define a single displacement reaction, and then we're going to identify a reaction as combustion, synthesis, decomposition, or single displacement, or neither. And finally, we're going to review Unit 4, Day 6. Now, this actually has nothing to do with, or not much to do with what we're covering today, single displacement, but it has a lot to do with what we're going to cover Thursday and Friday, double displacement, and we'll talk about that later. All right, so let's get into single displacement reactions. But before we do, we need to review the definition of element and compound, because element and compounds will be a part of our definition for a single displacement reaction. So remember, an element is something that's made up of one type of atom. And so here are examples of elements. You can have a helium element of helium, so it just has a single helium atom. And then we have some molecules that are elements. Molecule means it's made up of 2 atoms. But in the case of an element, if your molecule is an element, it only has one type of atom. So H2 only has hydrogen atoms, O2 only has oxygen atoms, chlorine only has Cl atoms, sulfur only has S atoms, and ozone only has oxygen atoms. On the other hand, a compound is made up of 2 or more different types of atoms. So water is made up of oxygen and hydrogen. Methane is made up of carbon and hydrogen. Calcium fluoride is made of calcium and fluorine, for example. So if you have more than one type of atom, then you are dealing with a compound. So here are some examples of single displacement reactions. And what I want to do before I have you go over the definition with you, I want you to see what you notice in these reactions. And specifically, you want to think about how many reactants and how many products that you have in each of these reactions. You want to think about the type of reactants and products that you have. Do you have compounds? Do you have elements? Do you have a mixture of both? And then what are the atoms doing in this reaction? So if you want, you can pause the video now and just sort of think about what you notice about these reactions. Okay, so let's go into what a single displacement reaction is, and these may be some things that you've noticed. So first of all, a single displacement reaction, they're also known as single replacement reaction. And in a single displacement or replacement reaction, you have 2 reactants. So you see you start with 2 things. One of them will be an element, so O2, for example, is an element, and the other one will be a compound. Calcium fluoride is a compound. And you're going to form two products. So that will be, and your products will also contain an element and a compound, but they'll be different from what you started off with. So in the first example, we have calcium oxide as our compound, and F2 is our element. Now, what's happening here is that the atoms in the element on the reactant side will displace or replace an atom in the compound. So basically, oxygen, our element, replaced the fluorine in the compound calcium fluoride. So they just sort of like switched, right? So if you think of calcium fluoride as being a couple and oxygen being someone who's single, well, oxygen sort of just stole calcium's boo. So that's essentially what's happening here, sort of a switching going on. Now, one way that this is represented is using this sort of formula here. So what is this formula representing here? You're starting with A. A represents your reactant element, and BC represents your compound. Now, the reason why it's represented that way, A doesn't mean a single atom, it just means a single type of atom. So the element only has one type of atom, and your compound has two or more types, so B and C. And then they sort of switch, they can switch partners. So how do you recognize that in something like this? If you look at our first example, oxygen is our element, so I highlight that in blue. Calcium fluoride is a compound, so the calcium, our metal part, is is one type of element, and fluorine is another type. And then we form a new compound by switching the partners. So we switch the red with the blue, right? The green with the blue to form a calcium oxide, and then our new element. We can see something similar like that here with H2 and CO2 reacting together. So here the H2 is going to displace the oxygen, the hydrogen displaces the oxygen, and you form a new compound, methane, and you get a new element, oxygen. Now, in these first examples, we were showing the element A replacing the atoms in the compound that's represented by C, what's highlighted in green. But that doesn't have to be the case. A could replace B. So in these examples, it's similar. We have sodium replacing the K, the potassium here, forming a new compound and a new element. And the same thing here, sodium. Now in this case, our compound has a polyatomic ion. So remember, we treat this as a group, so that stays together. So the sodium will replace the calcium, and you have a new compound, sodium nitrate and calcium. Okay, so let's talk about some non-examples before I have you guys test this out. So the question is this single displacement or not? And you have to be able to explain it. And if it's not a single displacement, you have to describe what kind of reaction it is. So let's look at this first example. N2 plus H2 goes to form NH3. Is this single displacement? Well, the answer to this is no, it's not a single displacement. And here are the reasons why, some of the things that you may come up with. First off, we start with the reactants. We have two reactants here, which is what you do have in a single displacement. You'll have two reactants. But both of these are elements. They're only made up of one type of atom. So in a single displacement reaction, remember, one reactant must be a compound, right? And we don't have that here, so we know it's not a single displacement. You can also focus on the product. In a single displacement reaction, you have two products, but here we only have one. So that's another clue that this is not single displacement. And this reaction specifically is a synthesis reaction. You're combining two things to form one product. All right, let's look at our next example. Here's our next example. So is this single displacement? Why or why not? And if it's not, what is it? So this one's not single displacement. So let's talk about why, no, why not. So again, we're starting off with two reactants, which is what we do expect in a single displacement reaction. However, both of these reactants are compounds. And in a single displacement, one of the reactants must be an element. So that's one thing you may notice. Similarly, on the product side, we have two products in this case, but both again are compounds. So that's not right, because in a single displacement, one of the products must be an element. Now, this reaction will be classified as neither. We haven't learned this one yet because it doesn't classify as combustion, decomposition, synthesis, or single displacement, of course. So this one would be considered neither. All right, last example. Is this single displacement? It is. So, and we know that because we have two reactants. One is an element, so sodium, Na is an element, and the other is a compound, MgCl2. And we also have two products. One is an element, magnesium, and the other one is a compound, NaCl. Sorry, I just had to correct that with at the bottom there. So the other is a compound, that's NaCl is our compound. All right, so this is a single displacement. All right, now we have our CFU. So which of the following reactions represent a single displacement reaction? So you're going to study these reactions, pause the video now, and when you press play again, the answer will be revealed. Okay, the answer here is choice A. So this is the only reaction that has an element and a compound for the reactants and the products. And we see that we do a sort of switching here where the hydrogen displaces the oxygen and forms a new compound, and then the oxygen comes out as an element. All right, the next CFU for the non-single displacement reactions. So for the non-single displacement reaction, you're going to label them as synthesis, decomposition, combustion, or neither. Pause the video now. When you press play again, the answer will be revealed. Okay, so in this case, here are our answers. So B, it's a combustion reaction where we're reacting an organic molecule with oxygen to form CO2 and water. C is neither. So we have two compounds on the reactant and product side and doesn't fit any of the types of reactions we've studied so far. D is decomposition because we're breaking it down into reacting down into two or more products. And then E is a synthesis reaction. We're combining two or more reactants into one product. Okay, so that's all we really need to know for single displacement. But tomorrow and Friday, you're going to be learning about double displacement. So a double displacement reaction involves mixing two solutions, which are made up of ionic compounds dissolved in water. And when you mix those two solutions, you're going to make two new ionic compounds. So in order to be successful in this, you need to be able to learn how to write the chemical formula of ionic compounds. So what we're going to do today in order to help prepare us for that is review what we've covered in Unit 4, Day 6. We're going to review how to define an ionic compound, like what it's made out of. We're going to look at the common ionic charges. We're going to review polyatomic ions, and we're going to review how do we determine charge on a transition metal. And then finally, how to check if the chemical formula of an ionic compound is correct. So what you're going to do is in today's folder, you will find the Unit 4 Day 6 materials. Now you can review that by choosing to watch a video or read through the PDF. Since you've already seen it, you may not want to watch the video. You may just want to flip through the PDF. There will be questions in your exit ticket that are covered from that cover material from Unit 4 Day 6, not just the synthesis stuff. So you just want to keep that in mind that you want to review that. Of course, all your assessments now are open notes, so you are welcome to use the notes that are posted here to help you. All right, that's it for this video. Have a quality day.